Hi, grade nines. The last lesson that we're going to do in linear relations is something titled matching equations and graphs. And in this section, what you're going to do is you're going to be given a graph, a series of graphs, some equations, and you have to figure out which graph belongs to which equation belongs to which graph. And if we look at the first example, what we have here is we have three equations, we have three graphs, so we have to figure out which of these equations belongs to graph A, which of these belong to graph B, and which belong to graph C. The process to do this is just a little substitution into the equation. So what I'm going to look at is I'm going to look at each of these graphs, and I'm going to pick some points. For example, if I look at graph A, I know that there are certain ordered pairs that fall on this graph. So I can look at, for example, I know that this point here, I know this point and this point, and I don't know, maybe this point, all are on graph A. So this ordered pair here is 1, 2. So if I just made a quick table of values for this graph, it'd be a 1 and a 2. This would be a 2 and a 1, it looks like. And then the last one looks like that would be, what is that, 5 and -2. I'm just going to grab this and move it so I can actually work with it. Come here. 2 and a 1. And I think the last one we said was 5 and -2. So I know that these 3 points fall on graph A. So in order to match up the equation with the graph, each of these points will work in one of these equations. And it's a good idea to test more than one point, just because sometimes graphs, and I'll show you in a bit, share a common point, but the graphs are very different. So test at least 2 points to figure out which of these ordered pairs fit in to the proper equation. Let's fix that. And we've got 5 and -2, I think it was. So if I look at this first equation, y equals 3x minus 3, if graph A was to match up with this equation, each of these points would work in that equation because this is the equation of a linear relation, and these are all linear relations, so we have to figure out. So what I do is I substitute in. So if I take my x value of 1 and put it into here, then this equation should spit out 2 for y. So if I look at this one, I go x is 1, so 3 times 1 is 3, plus 3 does not equal 2. So I know right off the bat, just testing this one point, that this graph A does not belong to that equation. Well, let's look at this equation right here, x plus y equals 3. So if my x value is 1 and my y value is 2, 1 plus 2 does equal 3. So the first point works. So good start. Let's look at the next point. X is 2, y is 1, 2 plus 1 equals 3. Yeah, that works. And in this one, fx is 5 plus -2 is positive 3. So each of these points fits in to this equation. So graph A belongs to x plus y equals 3, or the equation for graph A is x plus y equals 3. So all we're doing is testing points. Now let's look at graph B here. And let's pick some ordered pairs off of this one. I know that this point is exact. Again, I'm picking exact points that I know. Don't try and guess what is in between here. Pick exact points on this to just make your life a whole bunch easier. And let's say I chose those 3. And let's say I just did a little table of values here for those 3 points. And I have, what is this? 1 over and 0 up. So that's 1, 0. This one is 2, 3. And this one is 3, 6. So those are 3 points that I chose that are on this line. Now I know that x plus y equals 3 is no longer available because we've established that that first graph belongs to that one. So now I've got 2 points, or sorry, 2 equations, and I have to figure out which of these equations belongs to graph B. So let's look at y equals 3x plus 3, and let's go through the substitution again. X being 1, so 3 times 1 is 3, plus 3 does not equal 0. 3 times 2 is 6, plus 3 is 9, doesn't equal 3. If I take this x value in, 3 times 3 is 9, plus 3 is 12, so I know that it's looking like it's going to be this one, but I'm just going to double check to make sure it works. X value of 1, I put in here, 3 times 1 is 3, minus 3 does equal 0, so that works. 3 times 2 is 6, minus 3 is 3, so it works there. 3 times 3 is 9, minus 3 is 6, so it looks like that graph B and 3x, y equals 3x minus 3 are a match, which means graph C belongs to y equals 3x plus 3. So again, all I'm doing is matching the equations to the graphs, and I do that by substituting ordered pairs from your graph into the equation. If all of the points work, then you know that they are a match. What you have to be careful of, as I said before, is you have to test more than one point. Now, the reason being, if I look at a couple points on a couple graphs here, for example, if I look at this point right here, okay, that is 0, 3. And if I look at this point here, that is 0, 3. So if I take this point and I plug it into this equation, it works. If I take this point and plug it into this equation, it works. So this point, 0, 3, works in this equation, and it works in this equation. And that's why you have to test more than one point, because these obviously are very different lines. But this one point works in both equations, and that's why you need to test more than one ordered pair just to be sure which equation matches with which graph. So that's just matching equations and graphs. It's just substituting into the equations, making sure the points work, and if they do, then you've got your match. Let's have a look at this next example. And we are, again, matching equations and graphs. Here's 3 equations. Here's 3 lines. There's graph A, which is the red one. Graph B is the green. Graph C looks like blue to me. So what I need to do is figure out which of these lines belong to which equation. And if I look at this one, and if you want, you can make ordered pairs for each of these graphs and then start to match it up. So let's look at, I don't know, let's do graph A. I'll just pick some ordered pairs. And so here's A, and let's go make a table of values. Here's X, here's Y, pick a few points. Again, pick points that you know exactly on grid lines. And let's go here. And so this ordered pair would be 1 over, and looks like 1, 2, 3, 2 up. So that's 1, 2. This ordered pair is 2, 4. And this ordered pair is 3, 6. So I'm just going to make a table of values for each of these. Graph B is in green. Let's do it in green. So here's B. And table of values, graph B. I don't know, let's do this one right here, which is -1, and it looks like 3. I'm not going to take 0, 0. Reason being is this point is on all 3 graphs. So I'm going to take this one, which would be 1 over and -3. And let's do this one, which is 2 over and -6. So there's that. And then the last graph, graph C, we'll take, I don't know, this one. Let's just do these three in a row here. So this is 3 and 3. This one here is 4 and 4. And this one, the last one here, looks like 5 and 5. 5 and 5. Got my X and Y. There's X, there's Y there. So I've just made table with values for each of these. Now I have to figure out which of these belong to which line or which table of values. Well, if I look at this first one right here, Y equals X. What that means is your Y value and your X value are exactly the same. Y is equal to X. So in this table of values, Y is equal to X. 3 and 3, 4 and 4, 5 and 5. The X values and Y values are exactly the same. So I know right now that this one right here is Y equals X. And if I look at any point on this line, for example, if I look down here, well, this is -5 and -5, -4 and -4, -3 and -3. So this one here is Y equals X. The next one is, I don't know, let's look at Y equals 2X and check it out. So in, for example, graph A, if I take these points and substitute them in, they should work every time. So if my Y value is 2, so if I put 2 here, equals 2 times 1. So 2 times 1 is 2, so that is going to work. If I look at this ordered pair, 2 and 4, if I go 2 times my X value, or 2 times 2, it does equal Y value of 4. And this one, if I go 2 times my X value of 3, it does equal my Y value of 6. So this table of values, or line, belongs to this equation Y equals 2X, which means the last one should be Y equals -3x. So if I take -3 times x, so -3 times -1 is +3. -3 times +1 is -3, and -3 times 2 is -6. So this equation, Y equals -3x, matches up with graph B. So again, same process, table of values, make sure the ordered pairs from each fit into the equation every single time. And that's matching equations and graphs. You'll notice that these equations in each of these don't have, for example, y equals, I don't know, 5x minus 3. They don't have this constant part. And what you'll notice about these graphs, in this case, is we don't have a constant part at the end of each graph. We just have y equals 2x, y equals -3x, in this case it's y equals x. All of these graphs will pass through the origin. Not a big deal, but it's just something that you'll maybe noticed that is different than these equations that we've seen in the past, these three. But again, that's matching equations and graphs. Take your ordered pairs, plug them into your equation, and if they work, that matches them up. Test more than one point, and you should be good to go. Last example we'll do right here. I have to figure out, I'm given 3 lines and 1 equation. I have to figure out which of these 3 lines match up with that equation. And again, what you need to do is take some points off of each line, test them in that equation, and it will work. For example, let's say I'm going to test line number 1, and I'm going to pick this point and this point. Again, pick 2 points. And so this ordered pair here in that first one, x and y, this ordered pair is, what is that, -1 and -1, looks like. Yeah, -1, -1. And this ordered pair is 0 and 2. And what I'm going to do is I'm going to see if these fit into this equation. So if I go 3 times x, so 3 times Negative 1 is negative 3 minus 4 does not equal negative 1. So I know that line number 1 does not belong with that one. Let's jump over to this one and let's test here. And let's test this one right here. So if I did this ordered pair, x, y, and this one is 2 and 2. And this one is 1 and negative 1. And I have my equation, and if I go 3 times 2 is 6, minus 4, does that equal 2? It does. So let's test another point. Let's go 3 times 1 is 3, minus 4 is negative 1. So this equation matches up with line number 3. All right, and if I tested line number 2, that one would not fit. So again, testing ordered pairs into the equation. If the ordered pairs work, that matches your equation with your graph. And that is matching equations and graphs. Again, there is a handout that will be attached for an assignment. Give that a try. If you have any questions, by all means, get a hold of us. Thanks.